This is the first video in the series of Math 071 Skills Support videos. Today we'll be talking about sections 1.3 and 1.4. There is a document posted on Blackboard called Skills Support 1314 Functions. So if you do not have that document in front of you at this point, hit pause and get the document. Most of Math 171 is about functions. And the first question asked is, what is a function? Well, a function is a unique relationship where for every input, there is exactly one output. So for every value that you put into the function, you get one value out of the function. For each element in the domain, that is the set of input values, there is exactly one element in the range. So your domain is your input, and the range, that is your output. And for each element in the domain, there is exactly one element in the range. So what we've got to be able to do first of all is use some formulas. So as you can see on the worksheet, we have several formulas, and you're just asked to plug in various values. As we go through this worksheet, I suggest that you try to work the problems first and hit pause on the video. Then after working the problems, you can watch the video, hear me talk about the problems that you've attempted, and make sure that you got those problems correct. So as we are working with functions, usually the input variable is an x. And that's especially here at first. A lot of times when we do applied problems, the input variable might be a t for time, or could take on various values, letter values. But usually, especially in the beginning, we use x for our input, and so those are your domain values. And then our output values, those are going to be the range values. And in order to come up with the y value associated with x, all you have to do is replace the x with the value given. So instead of putting x, I put 0. So y equals 2 times 0 minus 6. 0 minus 6 is negative 6. And so the 0 point is associated with negative 6. I do the same thing with the 1. So y equals 2 times 1 minus 6. So that would be 2 minus 6, which is negative 4. In our next one, we have our x and our y, and they are related by y equals x squared. So we have x values 1 and 4, and if we take 1, plug it in, we get that y equals 1 squared, which means y equals 1. And when we plug the 4 in, y equals 4 squared, so that would give us 16. Now, in both of these first two examples, these are examples of functions. The first one that we looked at was a line. This is called a parabola. Notice that the x is squared here. And if we take the x and we square it, then there will only be one y associated with each x. But in our next problem, we notice that there is a difference here. This time, our relation is defined with x being in terms of y. Now, that by itself does not eliminate the possibility of it being a function. You can take any equality and solve for any variable. But the fact that the y squared here does end up being a problem when we check for functionality. So let's plug in values just like we did before. 1 equals y squared. Now we take the square root of both sides. So you take the square root of 1, and I'm going to do this over here. All right. So we take, I'll do it down here actually. All right, here we go. So we're going to take y squared equals 1. I take the square root of both sides. Now that leaves me with y on one side, but that leaves me with plus or minus 1 on the other side. Whenever you take the square root of something squared, you have to realize that there are two possible answers there. Because -1 squared equals 1 and +1 squared equals 1. So there are two different possible y values that we could associate with that single x value. That in and of itself means that this is not a function. Now, just because something is not a function, that does not eliminate mathematical meaning. It just means that by the definition we started with, a function is a unique relationship where each input has exactly one output. So this input could be associated with two different outputs. That's what makes this not a function. Notice with the 4, if we say 4 equals y squared, using that same methodology, 2 times 2 is 4, but -2 times -2 is also 4. So here we get -2 or +2 as a possible answer. So again, two different y's associated with one x means that this is not a function. So in this next set, it says evaluate as indicated. And what we have here is called function notation. And we'll learn about that in class over the next couple of days, depending on when you watch this video in relation to the ones from the 171 class. You may have already seen this f of x notation used. But this f of x, this is called function notation. And here f of x just replaces the y. So it's just a way of saying this y value is what happens when we plug in x, and you just take whatever x value is listed there and you replace that x value with that x value. Here's what I mean. So if we had that function, and we only use this if it's a function. So we've got that function, so we take f of x equals -2x plus 18. So f of 5 equals -2 times 5 plus 18. Now notice where there was an x, we replaced that x with a 5. And so anywhere in the function that we had an x, we also replaced that with a 5. Then you just do the math. So -2 times 5 is -10 plus 18 would give us 8. And what that tells us is the point 5, 8 is on the function. So here we just plug in the 0. So again, instead of the x, we are going to put 0. Everywhere there was an x, we replace that x with 0. 0 over 4 is 0 plus 3, so that just gives us 3. F of -3, f of x equals 5 minus x over 2 plus x. Always be wary of your negative signs. One of the most common mistakes that people make when doing math in general is dropping negatives. So we've got f of negative 3 equals 5 minus, I'm going to put my negative 3 there, over 2 plus x. So f of negative 3, I put a negative 3 there. So when I do that, oh, and I should have also put a negative 3 there. So I replace all of the x's with negative 3's. Now, negative makes positive. So this top part is going to end up being 5 plus 3 over 2 minus 3. 5 plus 3 is 8. 2 minus 3 is negative 1. So that is negative 8. Plug in 1. So that just becomes the square root of 9, which is 3. Again, pay attention to your negatives. So when I plug this in, I have f of negative 3 equals, now notice I put those parentheses there, so I'm going to replace everywhere there was an x, I'm going to put in that negative 3. Now, put those square. So, if you put it in the calculator improperly, this could be a problem. There is a difference between negative 3 squared, that's negative 9, because that's going to take 3 times 3, which is 9, so it's going to square the 3, then it's going to make it negative. That's not what we're doing here. In this problem, we are taking negative 3 times negative 3, and a negative times a negative is a positive, so negative 3 squared gives us a positive 9 there. 2 times negative 3 is minus 6, so my end result is a 3. F of 0, so we have f of 0 equals 0 squared plus 8 times 0 plus 16. When we plug in zeros, life is easy, because 0 times anything is just 0. So my end result here is 16. Because 0 squared is 0, 8 times 0 is 0, bam. I'm going to stop this video here and we will pick up with part 2. So, good mathing.